Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting-edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student or professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Tracy Schloemer, who holds a master's in education from the University of Michigan, a Ph.D. from the Colorado School of Mines, and is currently doing a postdoc at Stanford. How are you doing today?
I am doing great. How are you?
I'm doing good as well. So to start off, I wanted to ask what made you choose your major for your bachelor's?
Yeah, so my bachelor's degree is in chemistry from the University of Michigan, and I totally fell into chemistry as an undergrad. Actually, I think when I applied to Michigan, I said in my essay I was going to be a lawyer or like a poli-sci major because I wanted to make a difference in the world. And that, from my background, was how I thought would be the best way to approach that. Well, one job shadow later before finishing high school really informed me that that wasn't really for me because I was really bored. So, anyways, I thought, okay, I'm good at math and science in high school, so I guess I will be a medical doctor. That's what you can do. I come from a pretty, my dad was in the military, my stepmom was a nurse, like that. That's what I knew in my life. So, anyway, so I end up at Michigan, and I ended up in organic chemistry my first semester freshman year, and it was one of those experiences where things just clicked, and I kind of had this moment of, wait, you can do that. You can do that with these molecules, these materials. I remember, an example of, transition lens glasses and how, you know, one or two bond changes allow glasses to go from transparent to clear fit. So that's kind of my science origin story. And it took me a couple of years to realize I think I'm not going to medical school. I think I want to do science, but I also love teaching. And so I'd imagine you're going to ask me about the education stuff, but it was always kind of a combination of both, and got involved in research as a junior. And here I am, uh, 15 years later, still doing chemistry and very applied materials.
Yeah. So after getting your master's, what was your first job?
My first job, I taught high school chemistry. So I decided to lean into teaching over leaning into research. And yeah, so I taught high school chemistry for 6 years.
Yeah. And how was that?
I think it's the most important job I'll ever have, to be honest. The impacts that you make. It's also, I think, the hardest job I'll ever have as well. But um, it is something I'm really, really proud of. And I grew a lot. And once I got a little better at my job, I'm really, really proud of what the opportunities I was able to give my students, and then seeing how they would rise to the occasion. It was just incredible. I was really into project-based learning and bringing those opportunities for my students.
So what'd you do after being a high school teacher?
So I was in the classroom full time for 6 years. And at that point, I had really felt like I hit a little bit of a crossroads, personally and professionally, and felt like I wasn't sure if I wanted to be in the classroom for my entire career. And so it was really great timing to consider going back to graduate school to expand the opportunities available to me in doing work in materials and chemistry. And I promise it's related to electrical engineering. We'll end up there, I'm sure, through your questions.
Mhm.
So
Yeah.
yeah, so that's how I ended up in a PhD program at Colorado School of Mines.
And what was your research about?
Yeah. So I did really, really interdisciplinary work. So my degree is in applied chemistry, but I worked alongside chemical engineers, electrical engineers, physicists in doing work to do research on a new type of solar photovoltaic system. So this is actually becoming a little bit more mainstream if you pay attention to solar technologies. They're called perovskite solar cells. And basically, this perovskite is this material that has a particular 3D orientation that allows for really, really good light absorption, like silicon. So replacing silicon with something that is cheaper to manufacture, and much more lightweight, which has really, really important implications when we think about deploying solar maybe in rugged environments where you don't want to carry a heavy solar panel, or in outer space where every gram you can shave off of a payload is a huge amount of money saved in terms of getting it into space. So anyways, so I worked in improving the operational durability of perovskite solar cells. So I was designing materials and then putting them into little tiny baby solar cells. So they were like 1 by 1 inch, not quite as big as you'd put on your roof. And then I would actually break them. My job was to break them and figure out what went wrong, and then kind of use this iterative cycle to fix things. And so that's what I did. So that's a very engineering mindset, and that ends up being a very interdisciplinary problem. I like to tell people, even though I'm a chemist by training, if you only have that chemist lens, or if I'd only had that chemist lens, I wouldn't have gotten very far. I would have really missed out on some of the other things that were going on in the system. And that's kind of my origins of getting towards kind of electrical engineering kind of work.
Yeah. So what'd you do after getting your PhD?
Yeah. So after my PhD, I was considering different options. I had a wonderful, wonderful opportunity at a perovskite solar cell startup that, you know, looking at the date today, they're doing really, really well. They're out here in the Bay Area. And I also had an opportunity for doing a postdoc. And so a postdoc is more academic research, but it's not degree seeking. So I get to do kind of some of the best parts of the PhD experience, which is doing research and developing my own questions and, you know, engineering solutions to these hard problems, but on that basic research scale. So with the hopes of maybe some of these technologies could be commercialized and scaled up later. So so I started this postdoc, and I had some very loose connections with who I'm working with today. His name's Dan Congreve. And I remember actually seeing some of his work highlighted on social media. It has nothing to do with solar. It has to do with kind of light conversion technology. So still using light to do cool things, but not for power generation, but for changing the color of light in really interesting ways to tackle some challenges in 3D printing. And so I was kind of hooked. And so there was kind of this loose network and loose link of, well, I like to solve really hard problems that scan from the chemistry through kind of the nanoscale and molecular, and the kind of system level. So like the hardware, or like how you actually use it in real life. So this looks like a perfect fit for me. So, I mean, really, in summary, I take on overly complicated challenges because they're fun. Because there's always so many different ways that you can tackle them. So that is the overly honest story of how I got connected with my postdoc advisor. I saw an ad, or I saw some of his work on Twitter, thought it was cool, and I was like, well, I'd like to work for him and do this stuff. And then it worked out.
Yeah.
So here I am, almost 5 years later now.
Yeah. Do you see yourself staying in academia for the next part of your career?
I would like to. I have some ideas I'm really excited about on the basic research scale in terms of using nanomaterials for light-driven manufacturing and smart materials. And so I'm in the midst of really pitching these ideas to different institutions, and we'll see if my lab will find a home. So I would like to, but I also am very, very grateful to know a lot of wonderful people who have shared with me the types of things that they're doing in industry. And there are all sorts of stereotypes that, if you're going to go into industry, you are going to be a robot. It's going to be really boring. You'll get paid well, but you'll be really bored. And you have no control over anything, and you'll kind of lose this kind of creative spirit. And I've learned really quickly that is unequivocally not true. I had a great conversation with someone who did her Ph.D. here at Stanford and now is working at a super cool company making compostable straws and like foodware in really, really interesting ways. And she is the lead engineer, and everything she's describing is like the same kind of level of excitement and autonomy that you have in academic research. So we'll see where I end up. I'd like to be in academia, but ultimately my goals are to work with cool people, do cool things, and there are opportunities in a lot of spaces to do that.
Yeah. So if you had to give someone a piece of advice who's still in high school and wanting to go down a similar career path as you, what would you say?
Oh, I would ask you, how do you eat an elephant? One bite at a time. It is the weirdest metaphor, I suppose, but in terms of trying to take steps to where you want to end up, everyone starts from somewhere. Everyone has to make steps forward and keep going, because oftentimes the um, the culmination of all of these efforts are bigger than the sum of the parts. And so, but you just have to keep going and you just have to keep making progress. And sometimes things are unexpected or you might have detours, but as long as you make some sort of progress every day, as you continue on your journey and you start to look back, 2 years ago, 5 years ago, 10 years ago, I hope that you find yourself in a position that you're like, wow, I'm somewhere I never could have anticipated and planned for myself, but it's even better. Because that's how I feel when I look back at my own journey. So take it one step at a time, keep making steps forward, celebrate good things, be sad about the things that kind of stink, and then you just have to move on. So, yeah,
All right.
my best.
Thank you for joining me on the podcast today.
Awesome. Thanks for having me.